Before we took a break from school, we are looking at exponential growth and exponential decay. Both of these functions are very similar in terms of how they're set up. I've got growth over here and I've got decay over here. A represents the initial amount, so that's going to be the amount that you start with. R is going to be your either growth or decay rate. Now we're going to write this as a decimal. So as an example, 8% is 0.08 and 25% is 0.25. And then x or t, the actual exponent up here in the corner, that's going to represent the number of time intervals that have passed. I found an article from Wired, and this is dated March 20th. So it's about a week ago. It says, how fast does a virus spread? Let's do the math. And in the article, it says on Monday, March 15th, the US had about 4,000 confirmed cases. And you might go, hey, that's a tiny fraction of the country's population. What's all the fuss? By Wednesday, it had grown to around 8,000. And you might be thinking, okay, so every 2 days, we get about 4,000. And that'd be wrong because that's linear thinking. And it's actually much worse than that. With exponential growth, the number of new cases each day constantly increases. So if we graph this, we see that a line goes curving upward, and then we get into big numbers really fast. What you need to look at is the percentage increase. In this case, it doubled or increased by 100% every 2 days. Now, I want to do every single day, so I did the math for you. 100% or doubling in 2 days is about 41.4% growth every single day. At that rate, it will grow from 8,000 on Wednesday to 16,000 on Friday, and then 32,000 by Sunday. Now, this author actually did go back and look at the data and notes that the official CDC count did hit 16,605 by midday Friday, and then 32,644 by midday Sunday, and that's just the US. So what I want to do is I want to take this information and, assuming that we're not doing anything like a distancing, social distancing, or any preventative measures, I want to find out how fast is this thing actually going to be growing using our exponential growth model. So let's go to Desmos, and we're going to type in 4,000 as our initial amount times 1 plus 0.414. That's the percentage of growth every single day. This is all going to be to the x. Now, as you see, nothing appeared here. And that's because we have to change our window settings. So we're going to do the x values represent the number of days that have passed. Let's look at in a 2-week span. So let's do 0 to get 14, let's do 20, just so that we've got all the data right here. And then the y-axis, so this is going to be the number of cases in the US. Let's do 0 cases to, just to be safe, let's do 1 million. And now we see that we've got this line that appeared here, this curve. Now, what I want you to do is I want you to replicate this on your Desmos. So either use your phone or a computer. And we learned in class that we can take this and we can drag a point and we can find out how many in this problem cases we are going to have per day. So on the 8th day, that's going to be roughly 63,481. On the 12th day, that's going to be about 256,423. Now, looking at the calendar, we are the 26th of March. That information started on the 15th. So that's going to be 7, 8, 9, 10. We're on the 11th day. If we didn't have any precautions or any measures in place, 12, 13, 14, by this Sunday, the 29th, I want you to find out how many cases of coronavirus would exist in the US given this model. And then I want you to post your answer and then have a discussion with students. Figure out why your answer is right, maybe justify it, give some reasoning. And that's all I want you to do today. Thanks.